Hello friends, the flow meters play a vital role in instrumentation system. There are various types of flow meters. In this video, we have explained some multiple choice question answers related to flow meters. If you like the video, please hit the like and subscribe button and don't forget to press the bell icon. The first question is identify the correct statement regarding the positive displacement flow meter, and the options are option A, it measure mass flow rate, option B, it measure volumetric flow rate, option C, it measure dp flow rate, or option D, all of above. And the right answer is option B, it measures volumetric flow rate. Next question is, which is the correct statement for positive displacement flow meter? Option A, it requires AC power for their operation. Option B, it requires DC power for their operation. Option C, it requires both AC and DC power for their operation. Or option D, it do not require any power for their operation. And the correct answer is option D, it do not require any power for their operation. What is the straight run requirement in positive displacement flow meter? And the options are option A, 3D in upstream and 5D in downstream. Option B, 28D in upstream and 7D in downstream. Option C is 10D in upstream and 20D in downstream. Or option D, no straight run is required in upstream or downstream. So the correct answer of this question is option D, no straight run required in upstream and downstream. Yes friends, positive displacement flow meter is a mechanical flow meter which do not require any upstream and downstream straight run because it measures the volumetric flow rate of the fluid. Next question is, what is the main disadvantage of positive displacement flow meter? Let's see the options. Option A, low accuracy. Option B, high power consumption. Option C, it has moving parts. Or option D, it is not suitable for viscous fluids. And the correct answer of this question is option C, it has moving parts. Yes friends, positive displacement flow meter is having moving parts. Due to these moving parts, it needs more maintenance as compared to other flow meters. Next question is, identify the correct statement for positive displacement flow meter. Options are option A, its measurement is not affected by viscosity of fluids. Option B, its measurement is affected by the flow turbulence. Option C, its measurement is affected by temperature of fluid. Or option D, its measurement is not affected by viscosity, temperature or flow turbulence. And the correct answer of this question is option D, its measurement is not affected by viscosity, temperature or flow turbulence. Next question is, The differential pressure flow meter work on which principle? Let's see the options. Option A, Bernoulli's theorem. Option B, Faraday's law. Option C, time of flight. Or option D, Doppler effect. And the correct answer of this question is option A, Bernoulli's theorem. Question is, what is the Bernoulli's principle used in differential pressure flow meter? Let's see the options. Option A, pressure drop across the constriction is proportional to the square root of flow rate. Option B, pressure drop across the constriction is directly proportional to the flow rate. Option C, the pressure drop across the constriction is equal to the flow rate. Or option D, none of above. And the correct answer is option A, the pressure drop across the constriction is proportional to the square root of flow rate. The question is, what is the major disadvantage of differential pressure flow meter? Let's see the options. Option A, it has low accuracy. Option B, it is expensive. Option C, it creates a permanent and relatively high pressure drop. Or option D, it is not suitable for bidirectional flow measurement. And the correct answer of this question is option C. It creates permanent and relatively high pressure drop in the pipe. Yes friends, this is the only disadvantage of the DP flow meter because it has high accuracy, less expensive, and it is also suitable for bidirectional flow measurement. So the correct answer is option C. It creates a permanent and relatively high pressure drop across the pipe. The question is, in differential pressure flow meter, the differential pressure can be developed by using. Let's see the options. Option A, orifice plate. Option B, flow nozzles. Option C, venturi tubes. Or option D, all of these. And the correct answer of this question is option D, all of these. Yes friends, in differential pressure flow meter, the orifice plate, flow nozzles or venturi tubes all can be used to create the differential pressure. Next question is, ultrasonic flow meter work on which principle? Let's see the options. Option A, Faraday's law. Option B, motion mechanics. Option C, Doppler effect. Or option D, Hall's effect. So the correct answer of this question is option C, Doppler effect. Yes friends, the ultrasonic flow meter work on the principle of Doppler effect. The next question is, the ultrasonic flow meter uses which waves to measure the flow rate? Let's see the options. Option A, sound waves. Option B, radar waves. Option C, light waves. Or option D, all of these. The correct answer of this question is option A, sound waves. Yes friends, the ultrasonic flow meter uses ultrasonic sound waves to measure the flow rate of the fluids. Identify the correct statement regarding the ultrasonic flow meter. Let's see the options. Option A, in no flow condition, the frequencies of transmitted and received waves are not same. Option B, In no flow condition, the frequencies of transmitted and received waves are same. Option C. In flow condition, the frequencies of transmitted and received waves are same. Or option D. All of above. The right answer of this question is option B. In no flow condition, the frequencies of transmitted and received waves are same. Yes friends, according to Doppler effect, in no flow condition, the frequencies of transmitted and received waves are same in no flow condition. Next question is, ultrasonic flow meters are suitable for option A. Non-conductive fluid only, option B. Conductive fluids only, or option C. Both conductive and non-conductive fluids. And the correct answer of this question is option C. Both conductive and non-conductive fluid. Yes friends, the ultrasonic flow meters are suitable for both conductive and non-conductive fluids. Next question is, which is not correct regarding the ultrasonic flow meter? Let's see the options. Option A, low installation cost. Option B, it can be clamped on existing piping and no need to shut down the process. Option C, it can create a pressure drop across the pipe. Or option D, it can measure the bidirectional flow. And the correct answer of this question is option C. It creates a pressure drop across the pipe. Yes friend, option C is not correct because ultrasonic flow meter does not create any pressure drop in the pipe. Rest of all options are also okay. The installation cost of ultrasonic flow meter is low. It can be clamped on the existing piping and no need to shut down the process. This option is also correct. And it can also measure the bidirectional flow. So the correct answer is option C. It creates the pressure drop across the pipe. It is a wrong statement. Next question is, the electromagnetic flow meter work on which principle? Let's see the options. Option A, motion mechanics. Option B, Doppler effect. Option C, Seebeck effect. Or option D, Faraday's law. So the correct answer of this question is option D, Faraday's law. Yes friends, electromagnetic flow meter work on the Faraday's law principle. Next question is, the electromagnetic flow meters are suitable for which type of flow media? Let's see the options. Option A, non-conductive media. Option B, conductive media only. Option C, petroleum media. Or option D, all of these. So the correct answer of this question is option D, conductive media only. Yes friends, the electromagnetic flow meter can measure the flow rate of conductive media only. So the correct answer is option B. Question is, in electromagnetic flow meter, the fluid passing through flow meter work as. Let's see the options. Option A, insulator in magnetic field. Option B, conductor in magnetic field. Option C, source of magnetic field. Or option D, sensing electrode. And the correct answer of this question is option B, conductor in magnetic field. Yes friends, the fluid passing through electromagnetic flow meter work as conductor in magnetic field, and a proportional electromotive force is generated in the conductor. Next question is, identify the correct statement regarding the electromagnetic flow meter. Let's see the options. Option A, it can measure the flow going up in the vertical direction. Option B, it can measure the flow going down in the vertical direction. Option C, it can measure the flow in vertical direction either going up or going down. Or option D, none of above. So the correct answer of this question is option A, it can measure the flow. Next question is, in vertical which direction of the following is not true regarding the electromagnetic flow meter? The flow going up in the vertical direction. Option A, so the correct are not suitable for non-conductive fluid. Option B, they are not suitable for hydrocarbon, gas and steam media. Option C, the pipe must be full of flowing fluid for proper measurement. Or option D, the straight run is not required in upstream and downstream. So the correct answer of this question is option D, straight run is not required in upstream and downstream. Yes friends, option D is not correct regarding the electromagnetic flow meter. All other options are correct for electromagnetic flow meter. So the right answer of this question is option D, because it needs a straight run in upstream and downstream of 3D and 5D. Next question is, why straight run is recommended in flow meters upstream and downstream? Let's see the options. Option A, to maintain the pipe full of flowing media. Option B, to create the flow turbulence. Option C, to minimize the flow turbulence. And the correct answer of this question is option C, to minimize the flow turbulence. Yes friends, to minimize the flow turbulence, straight run in upstream and downstream is recommended. So the correct answer is option C. Next question is, the Coriolis Mass Flow Meter work on which principle? Let's see the options. Option A, Kármán vortex street principle. Option B, Faraday's law. Option C, Doppler effect. Or option D, motion mechanics. So the right answer of this question is option D, motion mechanics. Yes friends, Coriolis Mass Flow Meter work on the principle of motion mechanics. It is having a vibrating U-shaped vibrating tube. Next question is, which flow meter is having U-shaped vibrating tube? Let's see the options. Option A, magnetic flow meter. Option B, vortex flow meter. Option D, differential pressure flow meter. Or option D, mass flow meter. And the right answer of this question is option D, mass flow meter. Yes friends, mass flow meter is having U-shaped vibrating tube inside the flow meter. Next question is, Which is the best suited flow meter for gas media? Let's see the options. Option A, magnetic flow meter. Option B, vortex flow meter. Option C, thermal mass flow meter. Or option D, mass flow meter. And the right answer of this question is option C, thermal mass flow meter. Yes friends, thermal mass flow meters are best suited flow meter for measurement of gas media. Next question is, what is the working principle of thermal mass flow meter? Let's see the options. Option A, heat conductivity of fluids. Option B, heat generated by fluids. Option C, heat emission of gas. Or option D, none of above. So the right answer of this question is option A, heat conductivity of fluid. Yes friends, the thermal mass flow meter work on the principle of heat conductivity of process fluid. Next question is, which of the following is used as flow sensor in thermal mass flow meter? Option A, magnetic coil. Option B, heater coils. Option C, two RTDs. Or option D, temperature controllers. So the right answer of this question is option C, two RTDs. Yes friends, two RTDs are used in a sensor tip of thermal mass flow meter. One RTD is heated by an integrated circuit and it functions as flow sensor, while a second RTD acts as a reference sensor and determines the gas temperature. So the correct answer is option C, two RTDs are used as a sensor in thermal mass flow meter. The question is, the conveyor based method is used for measurement of flow of option A, solids, option B, liquids, option C, gas, or option D, all of these. So the correct answer is option A, solids. Yes friends, conveyor based method is used for measurement of solids. So the correct answer is option A, solid. Next question is, for liquid flow rate measurement, which of the following method can be used? Let's see the options. Option A, conveyor based method. Option B, Bourdon tube method. Option C, Coriolis method. Or option D, heat conductivity of fluid. And the correct answer of this question is option C, Coriolis method. Yes friends, Coriolis method can be used for flow rate measurement of liquids. So the right answer is option C. Next question is, which of the following is used to create the flow obstruction? And the options are orifice plate, option B, venturi tubes, option C, flow nozzles, or option D, all of these. So the correct answer of this question is all of these. Yes friends, orifice plates, venturi tube and flow nozzles, all of these can be used to create the flow obstruction. And the question is, what is the purpose of orifice plate in differential pressure flow meter? Let's see the options. Option A, to increase the flow. Option B, to reduce the flow. Option C, to reduce the differential pressure, or option D, to create the differential pressure? And the right answer of this question is option D, to create the differential pressure. Yes friends, in differential pressure flow meter, the orifice plates are used to create the differential pressure in the pipe. So the right answer is option D.